Hello and welcome back to Calculus1. It's my radio voice. Wow, finally. So the most important lesson of integration, the one that is setting you up for Calculus 2. This is the most frequent integration technique because this technique is backwards chain rule. Chain rule was your most frequent differentiation technique. So now this is the backwards chain rule, therefore it must have the same importance and frequency in use. So what is the U sub? Well, certain problems, vast majority of integrals, right, are not basic integrals. You are perfectly fine. Well, we don't have to be dramatic. Hold on. You are perfectly fine in integrating e to the x dx. And the answer is?
E to the x plus c.
Plus c. There it is. At plus c. So e to the x, the derivative of e to the x is e to the x plus c. But then what happens is you get to e to the 3x dx. And this is no longer basic integral. Right? Now some of you memorize this formula and you know that the answer is e to the 3x over 3. But why? How? There's plus c too. So we can use this particular problem to describe the basics of U substitution. See, U substitution is, like having a bad attitude. Oh, this problem would be so easy if this stupid thing over here was just one variable, like U or X or Y or whatever. So if this exponent was a single variable, then we would have this problem and I would not have to bother myself with this, right? So it's kind of, you sense the attitude, right? So you actually do that. You define the thing you don't like as a single variable to transform the problem and make it easy. Because now, with this u equals 3x on a side, you are allowed to go e to the u. But there's no free lunch, right? What happened is, when you changed your variable from x to u, your dx, which is in terms of x, has to also change to du. All of your variables across the board have to be of the same kind. And that kind is, now you want u, let's go and change it into a u. Now, you take the derivative over here, so du dx is equal to 3. And when you ship dx to the other side, just like you did in the differential, you see that your dx can be replaced by du divided by 3. Bueno? See? Okay. So now dx gets replaced with du over 3. Well, now this over 3 is the 1/3 that goes in front, and now you just have a basic integral. Now, whether this integral has u's or x's, it doesn't matter. It's the same thing, right? Any variable is okay. So it's 1/3 e to the u plus c. Okay. Are we done? No. We are not done because the problem was posed in x's. And your answer now has u's. That's not good, right? So we have to go back to the x variable because our problem was posed as x variable problem. to remember this easier, you can always say to yourself, right, I don't care about u, I care about the x. Which means you can go like this. Here we go. And you get your answer, which is exactly what I promised you at the beginning, right? You're going to get e to the 3x divided by 3 plus c. So the entire procedure depends on your ability to properly choose, and your ability to properly choose u sub depends on knowledge of what are the basic integrals and what are not the basic integrals. So integral of, let's say, x times sine x squared dx. So looking at this integral, what would be the thing that should bother you the most? X times sine. Sine x squared. Because you know the way to integrate sine x. You don't know the way to integrate sine x squared. So, you know, I know x, right? I know x. X is cool, but sine x squared is definitely not cool. So this is where the attitude kicks in. If I just had sine x, life would be better. But I don't. So how about I change the thing that I don't like into something I like and see if we can patch the problem. So we are replacing x squared only with u. That brings us the derivative of 2x, and this is the time for you to also stop and think a little bit. When you do your integral, when you draw your integral again, right, and you're in the next row, you know you're going to have sine of u. But see, this needs to go out and this needs to go out. Because your entire new integral, it's like a face. I just know. Your entire new integral is only allowed to have u as a variable. So, these are the two things that you have to remove. Do you have enough building blocks to remove them? And you already said yeah. Because du is equal to 2x dx. So I hope you see x dx there. So what's the only thing that is bothering you? 2. Move it to the other side. So your x dx is equal to du over 2. And that's your, here I'll underline it, x dx turns into a du over 2 because of this. So now your integral is 1/2 integral of sine u du. That's your integral. So we went from something that is terrible to something that is a joke, which is a basic integral. What's the integral of sine? Negative cosine. U plus c. Now we go and say, I don't care about u, I care about the x, right? So cosine x squared plus c. Yes?
Could you explain why in the first example we set it equal to dx, but in this one it's du?
Doesn't matter which side you have them on. You need to replace, see, you need to replace this piece as well.
Okay.
So dx is equal over du over 3. In my case over here, I have an extra x that I need to remove. So it's x dx that needs to be removed. Du over 2 this time.
You need to restate it here.
I'm sorry?
You need to restate the original problem with you.
Yes. So the entire problem gets switched to, this is changing the space, changing dimensions, changing everything, goes completely to a different state of existence. The x variables and u variables are not the same because they have the relationship, right? The two spaces have different relationship, right? So it's not linear either. So it's a completely different world. Integral of x plus 3 squared no coffin dx. Is this basic integral or something that we have to actually work hard on? It's a hard work?
You can just change the x plus 3 to u.
I could, but now that's actually labor that I don't have to do. Why?
If only this was just x squared, right?
Well, that's the idea, to make it a u square, right? But it's, guys, it's x plus 3 squared.
Just multiply that.
Yeah, just FOIL it out. Who cares, right? It's just x squared plus 6x plus 9 dx. This is a joke, right? So you are supposed to put a painting on a wall. You don't go with a sledgehammer, right? You have a little, you don't even use the framing hammer, right? Maybe you just use, like some people I know, the remote control. You use, small hammer, and you just put a little nail in the wall and you hang the painting, right? It's simple. You don't go with a sledgehammer. U substitution is a sledgehammer. So when it's simple, keep it simple. Right? But now, the next example, it's the same x plus 3 is back. But now, it's raised to 237th power.
Why?
Because we can. It's called mathematical gymnastics.
Oh, I thought you were, okay, I thought they were the same problem.
So now, go ahead, FOIL. I'll be back next year.
Isn't that like change it almost?
Yes, it is. We are doing U sub, which is the, well, since you went to the sub. Oh no, you went to the, that's.
Sorry, I was really hungry.
That, I know, I was kidding. I was hoping to make the joke because I thought it was a subway, but it's actually not a subway, so it's because we are doing U sub here, but it's still a sub, okay. Yes, the U substitution is backwards chain rule, which is why you see these similarities. Okay, so guys, the problem up there, it's a square. Even if it's cube, you can probably still cube it faster than actually going with the U sub problem. Now 237 and its exponent. No, I'm not foiling, okay? So what do? Well, let's go with the attitude. And it goes, ugh, right? If this was just U. So make it and see if it works. Guys, this is not the end of all techniques. Your chapter 7 in Calc 2 is going to introduce another 6 integration techniques. Yes?
I thought you were going to replace 237 with 201.
No, I can't replace number with a different number. What I can do is I can just make this to be a single, right, u to the 237, and now I just have dx is equal to du this time, right? Dx is equal to du because we have the linear correspondence up there. So now we integrate, becomes u to the 238 over 238 plus c, and then we go, I don't care about u, I care about the x, which is x plus 3, 238 divided by 238 plus c. Did you just say cool?
Yes.
Yes!
Wait, can we
Finally, the last class. Yes.
use the chain rule and go backwards?
That's how you're going to check.
Okay.
Let's say you care, right?
Yeah.
So what do? You differentiate your answer. The derivative of plus c is going to go to 0, so that dies. When you differentiate this, you will have to use the chain rule, and it will have to land here. This is why I liked integration. Integration is much harder than derivatives, but the beauty of integration is that once you're done, you can use derivatives to check your answer, and if you have exam only on integration, right, and you checked each one and each one checked out, walk out and just say, put 100 over here, right? No, because, just like when you, in algebra, you have the entire exam of only equations. And you get x equals 2, you get x equals 7, x equals a half, and you plug them back, and each one works, right? There is no gray area. There is no, I hope I did well. When you have integration question, if you are not lazy to do the derivative, and lazy, that's the bottom line. If you're not lazy to do the derivative, there is no I hope I did well. You either know you did it correctly, or you know you're 100% wrong, right? There is no let's hope, right? So like, all right. So the entire process of u substitution is, do you know basic integrals? All of them, from 4.9, which is on your exam on Monday, and then transforming the tougher integrals into easier integrals by realizing what is the one thing that you have to change so that you get that basic looking integral. Now, these things get complicated very fast because you start getting extra stuff floating around. And luckily, that's exactly the stuff that actually you needed in order for all of these things to work out. Without this x, sine x squared cannot be integrated. There is a method that you learn in the last week of Calc 2 to integrate this, and you actually don't even use the regular integration of trig. So, last night, we integrated a problem e to the x squared dx. This can be integrated in Calc 1 or Calc 2. And then at the end of Calc 2, you learn that you can transform this into something else and work it out. I don't want to spoil it for you. So,
Thanks.
you're welcome. So, yeah, the spoilers are bad, which is why I wear red the entire week. If someone says a word about the end game, I will literally kill that person, and then the blood doesn't show. That's why I wear red. Yeah, exactly. So, yeah. So now let's take a look at other examples. Spicier situation, for instance, right? And then I will give you some general guidelines and powerful technique on the way to solve these things. So integral of sine to the 9x cosine x dx. Okay, so before you run, this is one of the cheaper problems. No, this line is not straight. So, perfect. So what I want to introduce as a technique to solve U sub problems is something that I came up with as a student to understand these things better, and that was look for function derivative pair. So look for function derivative pair. Your function part will always be your u, and the derivative will end up working as a du. Function derivative pair. Every problem we did so far had the function and it had its derivative present as well. Now, why is that so? I'm going to erase this. Probably I shouldn't, but I will. The derivative of f of g of x is f prime with g plugged in times g prime. Right? We have some function and some derivative present in the problem. Because integration goes this way, derivative goes that way. So, with this being said, if I decide over here what's function and what's its derivative, I am immediately able to put in u and then figure out du and be done. So, you look at this and you say, oh, well, derivative of sine is cosine and derivative of cosine is sine. I can always fix the negative, right? So now which one do I pick? Ha-ha.
Sine. So you don't have to worry about it.
Well, negative is not an issue. The issue is the 9, exactly.
Oh.
So, when you make the wrong choice, this becomes terrible immediately. You made a terrible mistake, all right? Never wake up sleeping baby, right? So the same thing with these integrals. If you make a wrong choice, the hell breaks loose immediately. Now let me make a wrong choice and show you. U equals cosine x. That's the wrong choice. Du is negative sine x dx. I don't care about the negative because look, I fixed the negative right away. It's not a problem. Not a problem at all. Put two negative signs and done deal. The issue is that now this cosine becomes u, right? And I have 9 sines, but I don't have a 9 sines here. I only have 1 sine and dx. But in the problem I have 9 sines and dx. So when you make a wrong choice, they just don't fit. If you make a right choice, they immediately fit. U equals sine x, du equals cosine x, and then the dx immediately goes to the other side. You'll get used to immediately doing this without moving dx in the next. So, do I have this as a substitution? Yes! My sine x is raised to the 9. That's u to the 9. Cosine x dx is du. This whole puppy over here, there it is. See that? Matches. And you just get swapped. Just replace it as a unit. I got the polynomial. Out of this terrible trick question, I got a polynomial that we just go, oh, it's u to the 10 over 10 plus c. Yay! And then, I don't care about u, I care about the x, right? So we go 1 over 10 sine to the 10 x plus c. Some of you might have the issue of exponents with trig, so I'm just gonna low-key write that stuff over here. Sine to the 9x is the same as sine x everything to the 9. Bueno? Good. Which is not the same as sine x to the 9 on the outside, because that's just 9 to the x. So I'm just going to leave that there and move on. Oh, I'm going to actually add something in parentheses. ln is the same way. Because you are going to see ln squared, ln cubed, ln to the 5th. Right? So it works the same way. Okay. So what's next? Integral of x squared times 2x squared plus 3 dx. Okay, so, well, this is why I'm not nice, right? Is this a U sub problem? No, right? We cannot find function derivative pair. If you call your function x squared, what is the derivative? 2x. I don't have 2x, I have 2x squared. So that's no bueno. If I call this my function, what's the derivative of 2x squared plus 3? 4x. I have x squared. Right? So either one I pick, it's not good. But then luckily this is just a basic algebra problem. You just distribute this and you're done. Right? So when I put this on a test, I put a little smiley face next to it, right, like this, and then I get all of these answers that have nothing to do with anything. It's just distribute, okay? Do not lose sight of the basic integration, because foiling, squaring things, that's still present, right? These problems are designed for situations when the basic things fail. So if you have a basic integral, just as e to the x, just as 1 over x, just as x to the 10, right? Those are basic problems. You do them immediately. But then when you have something more complicated, can I use algebra rather than taking the sledgehammer right away, right? Maybe the algebra would help. So in this case it does, right? We have 2x to the 4th plus 3x squared dx, and this is basic, right? It gets to be 2x to the 5 over 5 plus x cubed plus c. So no u sub needed here, because we were able, I mean, it's not just no u sub needed, you can't use u sub. So u sub is not this more powerful technique that crowns over everything and just plows through every single problem. No, u sub is used when u sub is warranted, right? Other problems, u sub doesn't fit and you just can't use it at all. So now, Is there a version of this problem that I can do where the u sub would work? And the answer is sure. If I just have an x over here, and then I have a 2x squared plus 3, and I raise this to a 7th power, the x, for instance, I don't have to put that 7 there, but we can be dramatic. Now, I do have function derivative pair. So when are you able to use u sub? Only when you have function derivative pair. That's it. That's the only case when you are allowed to use u sub. Other times, it won't fit. U equals 2x squared plus 3. Now I'm going to teach you a different trick, so pay attention. Du is equal to 4x dx. Do you have 4x? No. So if you are a constant off, you can write it in, what you need, and then balance it on the outside. Write in what you need, balance it on the outside. Sometimes you need a half, you balance it with a 2 on the outside. Now we need a 4 on the inside, balance it with a quarter on the outside. This is my preferred method because it's less work than shoveling this division, right? The 2x and then 2x and then du over 2, and then you have to bring it here, du over 2, and then you kick half outside. I could have solved all of these problems with, 2x? Well, I don't have a 2x. Let me put 2x. And see, I just skip 4 steps if I do that, if I fix it. You can only fix constants. You cannot fix a variable to put in x inside and 1 over x outside of the integral. Hell no. Only constants. Because constants are allowed to jump in and out of the integral. Variables are not. So, I went with the attitude, if this was just one variable, then I would have just u to the 7 and I'm done. So, make it that way. When you take the derivative dictates that this 4 has to be there. And then you add the 4 that you need, and then you balance it on the outside with another 4. So now this becomes 1/4 integral. The parenthesis is u to the 7, and here's the orange stuff over here is going to be just du. Because, do you all see that the 4x dx? I'll put that orange right there. So you kind of have to look at 3 locations at the same time. So now it's 1/4 u to the 8 over 8 plus c 1 over 32. I don't care about u, I care about the x, which is 2x squared plus 3 to the 8 plus c. So please make sure you don't leave it in u variable. integral of this is spice level 5. Out of 4. X plus 3 raised to the 5/2. No. Later. Give me 40 minutes and then we do this. Let's do something civil. Sine 1 over x divided by x squared dx. This is do we have a function derivative pair? And how's your algebra? What's the derivative of 1 over x?
It's the same thing as 1 over
1 over negative 1 over x squared. Great. Do you have negative 1 over x squared anywhere? You just have 1 over x squared, so just make it negative. There we go. It's negative. So u is 1 over x, and the du is negative 1 over x squared dx. So this whole thing becomes negative integral sine u du. That's what's integral of sine. And that negative kills the negative we have. Mind blown, huh? Like, I know, right? Now, let's say we care. Check. The derivative of cosine 1 over x plus c. Derivative of cosine is negative sine 1 over x times the chain rule of 1 over x, which is negative 1 over x squared, plus 0. Negative and negative will cancel. We get sine 1 over x squared. Woohoo. I mean, you can put in more enthusiasm than that, but yeah. I miss this stuff. Because after all these years, it's not interesting anymore to me, you know? Like the whole class, just autopilot, you know? Every semester. Like a broken record. But I hope it's interesting to you, you know? It's like, oh, look at that, that's really cool. Time to go home and pass out. Let's see some examples from the textbook and see if we can get some spice out of the book. Hopefully we can. Well, I can come up with one. How about integral of dx divided by x times ln to the 6x? That's a nice one. Yeah. Like, that would be a cool t-shirt. I don't think anyone ever would debate anything to.
So what does that mean? If we look at it as, you know, height and width sort of thing, the function is dividing.
It's 1 over, so it's multiplied still, right? Because this dx, right, when you have a fraction,
Yeah.
what is 3 divided by 5? It's 3 times 1 over 5, right? So it's still multiplication of 2, and you have a fifth of an inch times 3 inches. It's okay, right? So you have the same thing here. I have Frozen song stuck in my head again. Any ideas? Any suggestions? Yes.
What if you take the 6 out of ln of x, make it ln of x?
You can't take 6. Because that's the part where the confusion kicks in. ln x to the 6 is 6 ln x. ln to the 6x is ln x to the 6th power.
Yes, that's what I mean.
Oh, that's what you meant.
That's what I meant. I'm sorry.
Okay, so let's do that.
Now, put it up to the top and make it a negative 6th power.
Okay.
And now, the ln of the derivative of the ln of x is 1 over x. You have a 1 over x there. And so that's...
So what's u?
U is the ln of x.
And the du?
Is 1 over x. Yes.
That's how you win. That's how you win. Integral u to the negative 6 du. Because this whole thing over here, dx divided by x is du. And then your ln x is u, so u to the negative 6. Nice. You went in there like... That was the one. Exactly. Negative u to the negative 5 over negative 5 plus c equals to negative 1 over 5 u to the 5 plus c equals negative 1 over 5 ln to the 5 x plus c. Boss. This is the time when you take the sunglasses. And if there was a YouTube compilation on this, it would be Tug Life. Good. That was a nice one. Now let's open the gates of hell, see what's cooking. Well, they have some nice stuff. I mean, you have to give it to them. It's like integral of 6x squared e to the x cubed dx. Yeah.
Can you bring the 6 out? Yeah.
Perfect. We can get rid of 6. They can escape integral, sure.
And I can separate e to the x. I can put parentheses on e to the x and cube that, right?
That's not the way. What is the function derivative pair? Because if you separate e to the x together, then you have to have another e to the x for du. What's x squared? What is x squared? Yes, so what was the function? X cubed. So x cubed and x squared are paired. because the derivative of x cubed is x squared. Yeah, sure, there's a 3 floating about, but don't worry about the constants ever, right? So we have, you kick 6 out, and then u is x cubed. Go from there. So we're about halfway through the lecture, which is good. 2/3. These are all plus C, right? We have definite integrals as well, right? Exactly. So kick 6 out. We have x squared e to the x cubed dx. Then we go u is x cubed, du is 3x squared dx. Now, you have a choice of stealing 3 from the 6, right? Because 6 is 2 times 3, right? So I can do that. And then we have 2 integral. That's my orange. So e to the u du, which is t to the u plus c, which is 2e to the x cubed plus c. All right, 2 more. Actually, another 2. Better than a tumor, right?
Oh my god.
Whatever. Integral of square root of x plus 3 raised to the 4th power divided by the square root of x dx. So what is the u over here?
Square root of x plus 3.
Very good. Okay. So now that you know that, if you were stuck at that point, what's the du?
1/2
dx. So what do I don't have?
Well,
1/2. So if I plug in 1/2 over here, I have to put 2 on the outside to balance it. So 2 integral of what? What do I get?
u to the 4th u.
Beautiful.
Yeah. U to 2 u to the 5th.
Yep. And then I don't care about u, I care about the x.
So the du just
The The du is all of this, the peanut. The peanut. That's the du.
so it cancels out.
What do you mean it cancels out?
Substitute. Yes.
This problem or in general?
This problem.
Okay, keep staring.
Good question. So integrals are opposite from derivatives, right?
Yes.
What's the opposite of ln?
E.
E. So is there any way to use E with integrals the same way you use ln with derivatives?
Because they're opposite in different senses. Inverse function and inverse operators are not the same thing. Right? So, there's that part. Did it click? Where's the disconnect? I circled, I made it into a peanut.
Yeah, I don't I don't get like I don't get how it goes away at the bottom. Like once you change it to du, like I get that, but where is it?
Well, is this our u?
Yes.
For u to the 4th, right?
Yeah.
And what's left? 1 over 2 root x.
Yeah.
1 over 2 root x times dx is du.
Yeah, and then after that, what?
No, when you integrate right, you take them out. It's just when you do the integration, the du and the integral sign go away because you use them up. That's like you remember what I said in class? I said square root of 9 is 3. You don't put another root because you used up square root of 9 to change 9 into 3.
Oh.
So the integral of x squared dx is x cubed over 3. You do not put other integral and a dx because you use them up to change x squared into this.
Okay.
So, alright, good. Woohoo? Woohoo, okay. Alright, let's see one more and lock the doors. Integral of tangent inverse of w divided by w squared plus 1 dw.
Those two cancel. So how you don't want this? About 10, 9, as the final. Oh, I see. As the integral. That's right. Because yeah, I feel you just get you. Yeah. But this is what I'm getting cancel out. Leaving just is like a minute. Yeah.
What's U? Inverse tangent of W. So what's du? So it just looks bad, right? It's a joke. So it's just a joke, right? Okay. Are we ready to end this with definite intervals? Use sub addition, obviously. What we have learned before is that area was calculated a to b f of x dx. And this a and b were actually your x1 and x2 values. And then you have the area under the curve, right? So please look at the screen. X, 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 X. They're all X's. What happens when we change the variable into a U? It becomes U, U. So what do we need to do now? In addition, we have to do U and U. Exactly. So now we have to switch the limits as well. Now clearly we are going to go with the most amazing example immediately. Integral from pi over 6 to pi over 3 of sine to the 6x cosine x dx. So what's my u? Sine x, very good. U is sine x. And what's the du? Cosine x dx. Nice. Okay, So that's all fun and games until someone loses an eye, right? Because now the limits I have up there are both x equals, without exaggerating. We need them now to be u's. Is there an equation that can transfer x's to u's? Do we have an equation which would transfer x's into u's? U equals sine x. Your substitution equation here is the one that will always transform your x limits into u limits. So your u1 bottom limit is going to be sine of pi over 6, and that is something you can calculate. How much is sine of pi over 6? Very good. All right, now how about u2? That's sine of pi over 3, right? That's something you can calculate. How much is sine of pi over 3? Very good. 3 over 2. See? No issues. So now, when we integrate, we get u to the 7 over 7, calculated from 1/2 to root 3 over 2. Do we go back to x? No. Our function is in terms of u, our limits are in terms of u, we just compute. So that step of going back to x is not present anymore because we have the values and we can compute at these values. So now this is 1 over 7, and then I have root 3 over 2 raised to the 7th power minus 1/2 raised to the 7th power. No plus c, because this is a definite integral. So now I have 1 over 7 times root 3 to the 7. Every 2 root 3's are creating a 3. So I have 3 of those pairs. That's 27 root 3. Right? Root 3, root 3, root 3. Why am I doing this? I regretted it as soon as I got here. So these two create a 3, these two create a 3, these two create a 3, and this one has no pair. So 3 times 3 times 3 is 27 root 3, because you're raising to the 7. Divided by 2 to the 7. 2, 4, 8, 16, 32, 64, 128. Minus 1 over 128. Is equal to 1 over 7 times 27 root 3 minus 1 over 128. You can multiply this. Next problem. Wonderful example, 66. Integration of 1 to e squared of ln p divided by p dp. You got this. So what is u in this case? ln. This? Yeah. Good. This problem is more of an essay than a math problem, right? It's like occasional number shows up. You can make a t-shirt. My math has no numbers. One of those. What do you know? Math without numbers. What do you know? So integral of u du. And now I have to use my u1 lower limit is going to be ln of 1, and that is 0. And the u2 is ln of e squared, which is a 2. Oh, come on, right? Can it be nicer than this? U squared over 2 from 0 to 2. Boom. One more problem, then we take the break. Then we talk about never-ending exams, right? You know what? I'm gonna let you pick. Which one?
Two ball.
All of them.
Oh, 62. Is that a good one?
62 is good one. Nice. Excellent. Integral 0 to 1 over 8.
There's a bird. A bird hit the window. Hit the window.
Consider the size of the bird's brain. Why is it weird?
It's not a bird.
I'm amazed that they don't hit the window all the time.
It's a turkey boulder. Turkey boulder.
No, that one would like projectile in and like take out the whole row.
It's pretty big. He's nice.
Where?
Where to the left? No. Go into this window here so you don't go too close to it or something.
What?
If you open the window, he'll go to your left.
Oh! Hi, buddy. So.
Now I can. He was immediately in the fight.
They have hollow bones.
People are running for dogs and cats. The only things you run is a tiger and out here. And there are certain things that you can win, right? Birds. What do you want?
I'll try.
No, you're actually succeeding. I mean, you're taking notes in this fashion. Yeah. Oh, maybe I should switch.
Are you guys talking about this problem or something else?
Don't we solve it?
We're doing 62.
Yeah.
Let me switch.
Like,
Yeah.
Square, it's not good.
Okay. Alright. Negative. Yeah. Okay. Yeah. Never mind, that's it. Okay. Plugging it back into. Yeah. Okay.
Accomplished, huh?
Okay.
Boss.
Super on
Hold on. Hold on. Too loud.
Okay, let's take a look at these. Good evening. So, U is what? Very good. 1 minus, I heard it. So what's the U?
negative 32. Oh, yeah.
X dx. Okay, fine. Great. So I don't have this negative 32, so I have to install that. So now I have negative 1 over 32. The top becomes du, and the bottom is square root of u. So this is now 132 integral of u to the negative 1/2 du. But hold on, we had limits. So u1 is 1 minus 16 times 0 squared. So how much is u1? is 1, right? And the u2 is a band. Minus 16, and then I have 1 over 8 squared. Now, by any chance, did you go 8 squared is 16 and then cancels? I hope you didn't. So, 1 over 8 squared, so it becomes a quarter. I'm going to compute this as 1 minus 16 over 8 times 8. So this cancels to 2 and this cancels to 4, so it's 3/4. What can you tell me about these limits? What can you tell me about the limits when you look at them?
You start from the smaller value.
Ah, the bigger number is on the bottom. We didn't have any problems like that. Now, who remembers 2 days ago when I pulled out a formula and I said, do you remember that we can switch the limits?
Does that mean that the area of the curve goes under the x-axis? Absolute value.
Nope, not the absolute value. If you flip your notes, guys, you're going to find the formula which, if you swap the limits, you kill the negative in front of the integral. So this now becomes 1 over 32, integral from 3/4 to 1 of u to the negative 1/2 du. The formula was given to you last class. I'm always suspicious of these non-standard ones. Integral out from a to b of f of x dx is a negative integral b to a f of x dx. So this minus here is because you swapped a to b to a. So I am swapping the order of limits. When I swap the order of limits, then you get the minus sign, which kills the other minus sign. And now you just perform the magic. 1 over 32, u to the 1/2 divided by 1/2, computed from 3/4 to 1, which is equal to 1 over, well, actually the half and 32, so 1 over 16, square root of 3/4 minus square root of 1, which is 1 over 16, no coffee, 3 over 2, minus 1. There you go. Now that's exact. You can go get decimals, but no one cares. So what you have witnessed in the past hour and a half is the most used integration technique, and you really need to know this one. Most of the methods in Calculus 2 are either just changing the problem so that you can use u sub, or using basic algebra to change the problem to use u sub, eventually. Most of the problems and other techniques. So everything boils down to this. So there will be part 2 for those of you who want to participate, right? Calculus will be back with vengeance in the second installment. What's left of this class is to have a review for the upcoming test, then to have the exam, then to have the review for the upcoming final, then to have a final, and that's it. So, such is life. So after the break, we'll resume and do the exam review.